Now let's see how to design a bus. What is the need of the bus? I just told you that if you don't have a bus, if you have to connect every two parts which are present, then it is going to take a lot of wires and it's going to be very confusing also. So the circuit design is going to be complex. Just to simplify the things, we want to collect all the wires together and put them at one place. That is the main intention of the bus. Okay, so assume that we have 4 resistors like this. Four resistors. Let's call it as resistor A, resistor B, resistor C, resistor D. And for the sake of simplicity, assume that all these resistors are 4 bits in size. Normally we have a very large number of resistors and the size of each resistor will be generally 16 bits, 32 bits or even 64 bits. But just to make things simple, let's assume that they are all having 4 bits, right? So I'm just naming all the 4 bits. This is A0, A1, A2, A3, and similarly B0, B1, B2, B3, C0, C1, C2, C3, D0, D1, D2, D3. These are the corresponding bits in the 4 resistors. This is the least significant bit and it is the most significant bit. Okay, and now what we do is we'll use a multiplexer. In fact, we'll use 4 multiplexers in this case. How many multiplexers are required and what is the size of each multiplexer, you'll understand, but I'll directly take 4 multiplexers in such a way that size of each multiplexer is a 4/1. So assume that this is a multiplexer and then this is a multiplexer, this is a multiplexer, and how a multiplexer is designed and what are the gates used inside, that we discussed in digital. Please watch digital before you watch it. Okay, and now every multiplexer is a 4/1. So every multiplexer is going to take 4 bits as input and it is going to give 1 bit as output. I am going to connect the multiplexers like this. D0, or the least significant bit of all the resistors, is going to be connected to this particular multiplexer. Okay, I'm going to connect all the least significant bits to one multiplexer. Got it? And you also know that multiplexer is also going to have the inputs, and the input selected depends on the select lines. So let me number the inputs. Let us assume that this is 0 input, this is 1, this is 2, this is 3, like that. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay, and now I am going to connect the second least significant bit to the second multiplexer in the same way. So this one is going to get D0, D1, and this one is going to get C1, this one is going to get B1, and this one is going to get A1. Got it? Here it got D0, C0, B0, A0. Right? Similarly here also this one is going to get D2, C2, B2, A2, and here also D3, C3, B3, A3. Got it? Okay, now we are going to get the output here. So let's see how the output will be. So this is the output from one, and this is the output. This is the output from the other one, and this is the output from the other one. We call these 4 lines as the bus. We can use these 4 lines as the bus. So what is the reason? I'll just tell you now. Okay, now before that, let us assume that these two lines are the select lines. Let us say this one is S1 and S0. Two select lines should be there. Why multiplexer should have two select lines, isn't it? So since this is a 4x1 multiplexer, we are going to have two multiplexers, two select lines. For every 2 power n by 1 multiplexer, we need to have n select lines. Remember that. Okay. Now, what happens if you give 0, 0 here? So try to understand this one. Let us say S1 is here and S0 is here, right? So if you give 0, 0 to select lines, what happens? So if you give 0, 0 here, the input 0 will be selected across all the multiplexers, isn't it? If you give 0, 0 here, the input 0 will be selected across all the multiplexers. Then what will appear on the output? Output means in these 4 lines. If 0 is selected, what will come out of this? D0 will come. What will come out of this? D1, this D2, this D3. Therefore, what will you see here? You will see here D3, D2, D1, D0. Got it? In case if you give 0, 1, then what will be selected in all the multiplexers? The one selected will be C, right? Why? Here you will get C0, C1, C2, C3, which means on the bus C0, C1, C2, C3, right? And similarly, if you give 1, 0, then what will be selected? B will be selected. On the bus, B will be selected. If you give 1, 1, what will be selected? A will be selected, which means on the bus you will get A, right? So depending on what you have given for select lines, the corresponding register, the corresponding data from the register are going to be selected there. See, these bits I didn't connect them just so that just to avoid this overhead of loops, but then you can assume that D1 is connected here, C1 is connected here, B1 is connected here. Therefore, depending on what you give for these select lines, you can select a register. Understood this? And now, how can I make data to transfer from one register to the other register? Simple. You take this bus, you are going to take this bus and you are going to connect it to all of them. D2, which means the second significant, and D3, right? Now this one, the last line is the least significant bit, second least significant bit, third least most significant bit. Least significant bit, second least significant bit, third bit most significant bit. Least significant, second least, third bit most significant. Got it? So now let's see a small operation where I want to transfer the data from D into the register A. I want to perform this. Whatever is present in D, I want to write it to A. For that, what I should be doing is, first you give the select lines so that the data from D will be selected onto the bus. So how can I give the select lines here, right? So just now I have shown you that if you select 0, 0, which means if you give 0, 0 here, the data from D will come onto the bus, right? So by giving the select line 0, 0, the data from D is now present on the bus. Therefore, it is now connected to everything. So all the registers are actually connected to this, but it doesn't mean that all the bits are going to be overwritten with that information. All the registers are not going to be overwritten. Only the register whose load input is activated at that time will receive this information. Got it? So first, what did we do? We have placed the information from the register D on the bus, and now at the same time, which means when the resistor is present here, at the same time I am going to apply the control signal load to whom? A. Let us say this is the control signal load. Every resistor is going to have the control signal load, right? So to this control signal load I am going to apply 1, right? So I have placed the information onto the bus, and therefore that information is actually available at the inputs of all the resistors, but then I just want it to be inserted into A, which means to be transferred into A. So only for register A I am going to activate load. So when I activate load, then the information will automatically pass into register A. This is how the bus is designed. Got it? So whatever units you have, you can now connect them here, right? Either if it is a memory or if it is ALU or whatever the unit it is, you are going to connect that unit to the bus, and then you are going to put the bus also at the inputs. Got it? So the output of that unit is going to be connected to the multiplexers appropriately, and the input is connected to the bus, right? Now the main question here is how many multiplexers are required, right? How many multiplexers are required? You can easily see that each multiplexer is able to transfer 1 bit from the register, isn't it? Each multiplexer, for example, if you see this multiplexer is responsible for transferring 0th bit of the register, first bit, second bit, third bit. Therefore the number of multiplexers required will be equal to the number of registers. You can note it down. Okay, the first point is number of registers, the number of multiplexers required is equal to size of the register or the number of bits in the register. Got it? And the next one is what should be the size of the register, right? How many what should be the number of inputs? So the size of the multiplexer will be equal to the number of registers present, because a multiplexer has to accept 1 bit from every register. Got it? Therefore we can say the number of inputs required for a multiplexer is equal to the number of registers. Got it? So the number of multiplexers is equal to the size of this one register, and the number of inputs for a multiplexer is going to be equal to the number of registers there. For example, they might ask you a question like this: there are k registers, each of size n bits. Then how to design the bus using multiplexers, which means how many multiplexers are required, and then what should be the size of each multiplexer. So see this, now for every bit we need a multiplexer, isn't it? The reason is every multiplexer is going to provide into the bus 1 bit from the register. Since there are n bits, how many multiplexers we need? We need n multiplexers, right? And then what should be the size of the multiplexer? Each multiplexer is going to take 1 input from every this register. Therefore we need k by 1 multiplexer. Size of each multiplexer should be k by 1, and the number of multiplexers required should be n. So we need n multiplexers, each of size k by 1, in order to implement the bus here. Got it? So such questions may be asked, but anyway I hope you understood how the bus is designed, right? It is not just we are going to connect the resistors, right? We can even connect the other units also. For example, we can connect the ALU. The output of the ALU will be connected to the bus, and to the input we give like this, right? And similarly we can have the memory unit, right? And for that memory unit also, the output of the memory unit will be connected to the multiplexers, and the input to the memory unit will be from the bus. Got it? So that is how all the whatever units we have, all the units can communicate using this bus, right? In general we'll have a 16-bit bus. So what is a 16-bit bus? Which means we are going to have 16 registers, right? And if the size of each register is 8 bits, then what should be the size of each multiplexer? right? So if the size of the let us say there are 16 registers, then how many what is the size of each multiplexer? It is going to be 16 by 1 multiplexer, right? And if the size of each register is 8 bits, then how many registers, how many multiplexers we are supposed to have? 8 multiplexers, and the size of each one has to be 16 by 1. Got it? Now we shall see how in practice how they are connected, right? How the actual registers are connected to the bus. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.